So this is going to be the last section we look at in chapter 2, which is 2.5. And it's on solving inequalities. But some of the inequalities we're going to look at today are not necessarily linear. They may have like an exponent of 2. So they could be a quadratic or higher. We generally won't go higher than an exponent of 3. Okay, but 2 or 3 is kind of what you'll see today. So one formula that we've looked at before, that's the formula for projectile motion. And we used it to figure out when an object was exactly at a certain height. Well, now we're going to use it to figure out maybe when an object is greater than a certain height or less than a certain height. Okay, that makes it an inequality. That's v sub 0. So when you put a sub 0 on something, it usually means like start value or like initial value. And if you did like v sub f, that would be like final value. Okay. So in this case, to find the height of an object, you need to know 3 things if it uses the projectile motion formula. One is how long since you threw the object. Has it been 3 seconds, 4 seconds? How much time has passed? What was the initial speed when you threw the object? And what was the initial height? Was the thing that you threw, was it like on the ground? So it started from ground level? Or were you standing on top of something maybe 20 feet tall and you threw it? So that's, again, a formula we've seen before, just putting it up there to remind you what it is. The negative 16, that's a number that always stays in the formula. That has to do with gravity. Also, in our problem, we always use units of feet and seconds. If you take other like classes in science, they probably don't use feet. They're probably going to use meters per second. Okay, but we use feet. It's just the way we do it. Okay, so in this problem, it says a ball is thrown straight up from ground level with an initial speed of 80 feet per second. So first thing I want to do is just take that information and fill it into the equation up above. Okay, so I'm going to start out with height equals, and what comes next that doesn't change? The negative 16t squared. That never changes. Now the next part does change. Plus the initial velocity times the time. What's the initial velocity here? Yep.
80 feet per second.
Plus 80 times the time. Plus the initial height. What's the initial height? 0. So I'm not even going to put it. If the initial height was a number other than 0, I'd put that number. Okay, but it's just 0. So there's our equation that represents what's happening here. Now, what do they want to know? They want to know, when is the ball at least 64 feet above the ground? Okay, when is it at least 64 feet above the ground? So that means they want to know when the height is, what does at least 64 feet mean? What is it?
Greater than or equal to.
Yeah, greater than or equal to. So that's the question they want me to figure out. When is the height greater than or equal to 64? Well, to figure that out, I need a formula for the height. Well, that's exactly what the projectile motion formula is. This is a formula for the height. So we just take that and we put that in for the height. Let's see. So we're going to have negative 16 t squared plus 80t is greater than or equal to 64. Right, now we're going to, they don't say how to do it. Oh yeah, they do. Use graphic calculator. So we're gonna use the graphing calculator now. Now we've done a couple methods. We've done some methods where we find a root. We've done other methods where we do an intersect. We're gonna do this as an intersect. Okay, so what that means is you're gonna put what's on one side in y1, and you're gonna put what's on the other side in y2. Okay, so let's start with this. So negative 16, remember you gotta use x as the variable, don't use t on the calculator. No, you can't, because the t will just, it'll think t is a number. Like you can store a number in a letter on the calculator. It'll just think t is some number that you stored, not a variable. So negative 16x squared plus 80x, put that in y1, and put 64 in y2. Now, when you draw something with an exponent of 2, what shape is it? It's not a line. A line would be y equals mx plus b.
This is quadratic.
This is a quadratic. So what's that look like? Yeah, it's going to have like a U shape to it, right? It's going to look like a parabola.
But it's going to be upside down.
But specifically, yeah, it's going to be upside down because that negative flips it. Right? So let's think about the window. What's the minimum amount of time that could go by in this problem?
0.
0. That means no time has gone by yet. You haven't thrown the object. The maximum amount of time, well, that's how long it's in the air. We don't know that. So let's just leave it at 10. Y is the height. What's the minimum height that this object could have?
0.
0, right? Ground level. It can't go negative. Negative would mean it's going like underground. And the maximum height, well, we want to know when it hits 64. It's probably going to go even a little higher than that.
Let's go 70.
So we go 70?
80.
Yeah, we'll try 80.
Oh, do you want like the full?
Yeah, I want to see the full thing. I might even try 85.
So I think like 85.
Let's try 85.
I think so. 85 sounds good.
And then hit graph.
We got some guy for
Even higher.
All right, so it does go a little higher. It's not
110.
it's not critical that we figure out how high it goes, technically, because the question's not asking what's the maximum height. We can see 64. So that's really all you need to see. But if you do want to see the maximum height, let's try 110.
100 is perfect.
Yeah. Okay, so we want to know when we are above 64 feet. So what does that mean in that picture? We want to know when we're above what? So we do have to find the intersection points, but we want to know which graph is above which graph.
One graph was above the slope 0.
Right, we want to know when the blue one is above the red one. Okay, that's what we want to find. So the first thing we have to do is find where they're equal. Now, when is the ball at least 64 feet above the ground? I was just making sure we were supposed to have the equal to there, and I think we are. If it said when is the ball above 64 feet, then you'd have to take out the equal to. Okay, because it can't be 64 if it says above. All right, let's find both of those intersects. So second calc, and which option do we use? 5. Now, you have to pick a point on each graph that you're using. So the blue one, the red one. Now, does the guess matter?
Yes.
Yes, it does. Because you got 2 of them. So I'm going to move my guess closer to the one on the left. And then if someone else can do their guess closer to the one on the right, we'll get both of them. So when you do the one on the left, you get 1 second.
4.
The other one's 4. So this point is 1, 64. And this point is 4, 64. So when is the ball above or equal to 64 feet?
In between 1 and 4 seconds.
In between 1 second and 4 seconds. So the time has to be greater than or equal to 1 second. and less than or equal to 4 seconds. So that's it's a conjunction between 1 and 4. Okay, any question on that? All right, let's try one more. Okay. How long does the ball stay in the air for? Well, if the ball is in the air, what does that mean about it? The height is above 0. So that's basically what this is asking. We just did a question that we figured out when is the height above or equal to 64. Now we're answering the question, when is the height above 0? That's basically what this question means. All right, so the height, I got my formula for that still. Negative 16t squared plus 80t. And we want that to be greater than 0. Okay, so for this one, does anybody see anything on the left-hand side that is common to this term and that term? Something we could factor out of both.
Well, first I just want to ask, can we just like use the graph?
So for this one, yeah, you can use a graph, but this one we're going to do algebraically, and then we'll use the graph after. So something that both of these have in common.
4.
Yep, 4 is a number.
8.
8 is another number. 16 is the biggest number.
16t, actually.
Yep. And this part's optional, but we're going to take the negative out with it. So we're going to take out a negative 16t from both of those. Negative 16t. What's up?
Do you have to? Is it pivotal for the problem?
It's going to make what we're going to do next easier if you take out the negative 16t, the whole thing. Yeah. Okay. What would be left inside the parentheses here? Negative 16t times what is negative 16t squared? Yep.
T plus 5.
So that would be a t. And now negative 16t times what is 80t? Minus 5. Yep. You can check that by distributing it back out, and you'll see that it works. Any questions on factoring out the GCF? Okay. Now, look at what you've got there. You've got something times something, and it's going to be bigger than 0. Forget, for now, what's actually inside the parentheses. How can you multiply two things together and get an answer bigger than 0?
0.
What kind of number could you put here? And then what kind of number would you have to put here? There's actually a couple of different cases.
Everything that is not 5.
Can you put anything that's not 0 or less than 0?
So you tell me, what kind of number are you thinking to put right here?
1.
Oh, I was thinking about the other one with the t minus 5.
Yeah, don't worry about that. Just think in general. You have something times something coming out greater than 0.
Any number, any negative number.
Okay, so you're saying put a negative number here?
Yeah.
Okay, then what kind of number would you need here?
Any positive number.
What's a negative times a positive?
A negative.
A negative. That wouldn't be greater than 0.
Any negative number.
Okay, so you could have a negative in each spot, and a negative times a negative is bigger than 0.
Yep. Positive too, because if you do multiply.
So a positive here, and then what would you have here?
Positive.
A positive, yeah. So mathematically, there's two ways to multiply numbers together and get something bigger than 0. You either have a negative times a negative, or a positive times a positive. Okay. Any question on that idea? That's going to be important here. All right, now let's look at this right here. T stands for what?
Time.
Time. And time is always going to be what kind of number? Time is always a positive. So you're going to take something that's a positive and you're going to multiply it by negative 16, which means what's inside the first parenthesis is always going to be what kind of number?
Negative.
Right. This is always going to be a negative. Because you're taking a positive value and you're multiplying by negative 16. A positive times a negative is always going to make that first parenthesis a negative. So that's, you're forced into that. This always has to be a negative, which means t minus 5 would have to be what kind of number to have this whole thing come out positive?
Negative.
It has to be. You have to have t minus 5 come out to a negative number. So that way when you do a negative times a negative, you get an answer bigger than 0. So this case is impossible in this problem. It's impossible. This first parenthesis will never be a positive number.
Why?
Because it's a positive value for t times a negative 16. And a positive.
Oh yeah, I forgot. Because I was gonna say you can't just do a negative number for t and then a positive.
No, t can't be a negative number. No, t is time, so it has to be positive.
Yeah, no, because I forgot that like if you set t to a negative number, it has to be in both parentheses.
Yeah, and t can't be this. That's not allowed in this problem. Yeah. So now the question is just when is t minus 5 negative? If we can answer when t minus 5 comes out negative, that tells us how long the ball is in the air for. Okay, so let's see. When is t minus 5 negative? When does it come out less than 0? How would we solve that?
Plus 5.
Plus 5. So we get t is less than what? 5. Which means the ball is in the air basically for how long? Yeah, it's like less than 5 seconds. When it hits 5 seconds, the ball's back on the ground. So at like 4.9999 seconds, it's just about to hit the ground. So the ball is in the air just under 5 seconds. Any question how we figured that out?
You have to account from the beginning to when it's actually on the ground to start.
So that takes that into account by saying the ball is in the air less than 5 seconds. Yeah, it would take it into account. So it's like it's 4.999 seconds basically. If you say the ball is in the air 5 seconds, well, technically well, you can see it in the graph. If you look at the 5th second, 1, 2, 3, 4, 5, it hits the ground again. So technically at 5 seconds, it's back on the ground. Yeah.
Did you divide both sides by 16? Is that what happened?
No, I factored out negative 16t.
Yeah.
Okay.
I factored out the GCF.
Okay, gotcha.
If you couldn't factor out a GCF here, then we couldn't have solved this problem the way we did it.
Okay.
It wouldn't have worked. So I had to make this number a multiple of 16 to do what I wanted to do.
Okay.
Yeah. All right, let's look at, okay, we're going to do something a little different with this. All right, let's try this one. Okay, this one we're going to solve, and we're going to use the calculator. Okay, the first thing you have to do when you use the calculator, I'll put this down even though it's already done for us, is we got to make sure you have what number on one side. Yeah, when you're doing a quadratic, a lot of times that's how you want to do it. You don't have to. You can do a y1 and a y2 and do an intersect. That's what we did on the last problem. We did a y1 and a y2. But if you want to use second calc 0, if that's the option you you want to use, you have to get 0 on one side. So if you want to use second calc 0, get 0 on one side. If you don't want to use second calc 0 and you want to use second calc intersect, that's fine. You can do a y1 and a y2 and see where they cross. All right, but let's see what happens. Okay, so we are going to use a 0 in this problem because it's already set up to do it that way. Okay, type what's on the left in y1. 2x squared plus 9x minus 5. Don't put anything in y2. And for the zoom, what would be a good zoom to try to start with? Would be a good
Zoom 6.
Yeah, why don't we start with zoom 6? We know we're looking for a parabola. All right, it's not bad. We could adjust it a little bit so we can see the bottom. Which value do I have to make a little lower?
Y.
Yep, which one?
The min.
Yeah, if we go like negative 20, that'll probably work. Yep. Okay, now let's look at this picture. Okay. Make that a little bigger. All right. So first of all, we got to figure out what they're looking for. They're looking for the part of this graph that is above 0, or the part of the graph that is less than 0. Above 0. So you can really break this graph up into 3 parts. Okay, let me show you the 3 parts. So there's this part of the graph over here. Then there's this part of the graph down there, and then there's this part of the graph up here. How many parts of the graph are above 0?
2.
2. So then when we write our answer, it's going to have that symbol. All right? So we have to describe, we'll call them parts 1, 2, and 3. Which 2 parts are we going to describe?
1 and 3.
1 and 3. Those are the parts that are above 0. To figure out where it's above 0, what do you think we have to find in this picture?
Roots.
Yeah, we got to find both roots.
0.
Yep, we need that, and we need that. All right, let's find it. Okay, again, I'll do the one on the left. If someone can do the one on the right, that would be helpful.
Right is already 0.5.
It's 0.5?
Yeah.
Okay, let me do the one on the left. So we go left. Looks like it's negative 5, but just, yeah. All right, so this point is negative 5, 0. And this point is 1/2, 0. Okay, so those are coordinates. Okay, let's start with our first interval. Look at interval 1. What's the lowest x value you could pick and still land on the red section? And remember, it just kind of keeps going like that. What's the lowest x value you could pick and still land on the red section? Yeah, negative infinity. The further and further left you pick, you're just going to end up higher and higher and higher. You're going to end up above 0. You'll end up on that red section. Like if you pick negative 3, you're like way up there. So anything below negative, anything all the way down to negative infinity. And now, how high of a value can you pick and still be in the red section?
Negative 5.
Right. Can you include negative 5, or do you have to stop right before it?
You can include negative.
And stop before. You can.
So the question is it greater than or equal to 0?
Oh, sorry.
Or is it greater than?
It's like 4.9.
Right. So we can go as low
4.99.
as negative infinity. We can go as high as negative 5. Can you include negative infinity? No. You can't reach that. Remember, you never include negative infinity. Can you include negative 5?
No.
No. That describes interval number 1. Now we got to describe interval number 3. Okay, and remember, it's a U shape, and it just keeps going like that. What's the lowest X value you can pick and be in the blue section?
Infinity.
No.
Well, that's the highest X value you could pick.
Yeah.
So the highest is infinity. The lowest you can pick is 0.5 or 1/2. Can you include the 1/2? No. You can only include it if there's an equal to symbol. Can you include infinity?
No.
No, because you can't reach it. So what this is saying is if you pick a number between negative infinity and -5, or between 1/2 and infinity, you will get an answer that's bigger than 0. What happens if you pick a number between -5 and 1/2?
It won't be true.
You're going to be below 0. You'd be in section 2. That's the green section. So if they wanted to know where are you less than 0, that would be section number 2. So that's pretty much it. You just have to find the 2 intersection points and then go from there. Let's try one more. Let's try this one. You do need to type it in exactly the way it's written because we're not going to have to distribute this out, but the calculator is going to do it for us. So x plus 3, x minus 1, and we'll do zoom 6. Okay, perfect. So what are they looking for this time in the graph? Greater than or equal to 0. How many sections can you break that graph up into? Think about like every time it crosses the x-axis, that's a new section. Yeah, this one can be broken up into 4 sections. That's section 1. This is section 2. That's above 0. Section 3, I'll just leave that one in blue. That's below 0. And then section 4 is back above 0. So they want to know where we are above or equal to 0. How many sections are above 0? 2. And which sections are they? 2 and 4. So we need to describe all the numbers from here to here, and then from there, going on forever. So to do that, what do I need to find first? Yep, I need all my roots. Right, so second, calc. Actually, I think I can tell what they are. You should always check them, but I did this problem earlier. It's -3, 0, and 1. Those are the roots. But you can check them. So this is -3. This one is at the origin. And this one is that 1. Okay, so we got all the x values. -3. Remember, this is what you're focusing on. -3, 0, and 1. Those are the important numbers. Okay, and we said we need to describe interval 2 and 4. What's the lowest number you can pick and still be in interval 2? -3 is as low as you can go. What's the highest you can go and still be in interval 2?
0.
0. Can you include?
Yes, you can.
I think I covered the original problem.
Yeah, that's a good.
Yeah, but that's a good
Yeah.
Oh, there it is. It's down there. So yeah, it has the equal to. So I'm going to put the answer down here.
Let's go.
And then what symbol goes after that?
U.
Right? Because it's or. And what's the other interval that we can be greater than or equal to 0?
1.
That's the lowest.
Yeah.
And what's the highest?
Infinity.
Infinity. If you just keep going, you're just going to be higher and higher on the green section.
Bracket and then parentheses.
Right. You can include the 1, but you never can include infinity because you can't reach it. Okay. Any question on that? Okay, so that's yeah, that's that hard. We can try one more. We can try this one. So another graphing one. This time, is it set up with 0 on one side?
Oh.
No, we could make it that way. We could shift everything over. But let's just leave it the way it is this time. Let's put what's on the left in y1. So go y equals x cubed minus 2x squared minus 5x plus 7. And then put what's on the right in y2. 2x plus 1. Okay, I'll do zoom 6, see how it looks. So the one on the left is going to be the one that curves. The one on the right is going to be a line in y equals mx plus b. Okay. So they want to know where, just to kind of color code it here, this is the blue one. That's the red one. They want to know where the blue one is above or equal to the red one. How many sections do we have to break that up into?
3. Well, there's 3. Right? 1, 2, 3, 4.
Yeah, there's 4 sections. There's below, above, below, and then above again. How many sections is the blue one above the red one?
2. 2.
2. Yeah, just 2. I would say from here to there. We need to describe that. And then from here, just keeps going. So we're not going to calculate zeros this time. What do we have to find?
Intersection.
Yeah, we have to find the intersections. Okay, so second calc. I'll do the one all the way on the left. And then if someone can do like the one in the middle and the right.
Yeah.
Okay, so the one on the left is negative 2.26. Okay.
On the right is 0.75568.
So negative 2.26, that's as low as we can go and still stay in section 1. What's the highest I can go?
0.75564.
All right, so let's say 0.76. Yeah. Can I include where they're exactly equal to each other?
Yes.
Yes, I can, because it has the equal to. So that describes the x values you can pick to stay in interval 1. Or, now we need to describe the x values for interval 2.
3.5.
3.5. You have one more decimal?
3.5 is a 0.
3.50? Okay. So 3.50 is the lowest. Can we include it?
Yes.
Yep. And what's the highest x value you could pick and still stay in section 2?
Infinity.
Infinity. Yep. Any questions on that? All right. So last thing we'll look at in the last 25 minutes is part of 3.1. I don't know. We'll see what we get to. But those graphs that we just did, the one that had that curve to it, that was a polynomial. The U-shaped one that looked like a parabola, that's a polynomial. Right? And there's a couple things that a graph has to have to be a polynomial. So you can have exponents, but the exponents have to be non-negative integers. Non-negative integers. That means you can't have any fractions as exponents, you can't have any decimals, and you can't have any negatives. This is not a polynomial. X to the 3.5 power. No. You can't have decimals as an exponent. If you did like y equals negative 2x to the negative 3rd power. Nope, that's not a polynomial. You can't have a negative exponent in a polynomial. Okay, you can have exponents like 2, 3, 4, 5, 6, 7, 1, but you can't have decimals and you can't have negatives. I just said that. Okay, so some examples of things that are polynomials. That's a polynomial. Y equals 3x plus 2. That's a linear polynomial. Actually, I think I'm going to say that in a minute. Yeah, I'll hold off on saying that. So y equals 3x plus 2. Here's another one. 8x squared plus 4x minus 5. That's a polynomial. We can do a cubed one like we did in the last section. Right, as long as you don't have any negative exponents on your variable and no decimal or fractions. You can have a decimal like right here. That's fine. Minus 4.3. That's not a decimal on the exponent. That's just the decimal at the end of the problem. Any question on the difference between having a decimal as the exponent versus at the end? Okay. Now, if we look at it, this number is something special. Okay, so is this number. Does anyone remember what, if you look at the term with the biggest exponent, that exponent is called something. It begins with a D. Do you remember?
The decimal is called what?
This biggest exponent, the term with the biggest exponent, like in this case it's a 2, in this case it's a 3, in this case it's a 1. Those numbers describe the something of the polynomial. It begins with a D. Yep.
Degree.
Yep, the degree. So let me write that down. So the term with the highest exponent tells you the degree of the polynomial. So in the first problem, just number this like number 1. In number 1, the highest exponent is a 1, so the degree would be a 1. In question number 2, the highest exponent is a 3, so we'd say that that's a degree 3. In the third problem, the highest exponent is a 2, we'd say that that one is a degree 2. Now, if you did something like this, let's say you had 8x cubed plus 0x to the 4th minus 5.
It would still be the 3.
It would still be the 3 because you might say, well, wait a minute, this has a 4, right? But you're really multiplying something by 0, so you might as well not even write that. That's not even there. Okay? If you multiply something by 0, that doesn't count. So it's the term that has the highest exponent as long as this number in front isn't a 0. Okay? How about if I did this? 3x squared minus 5x cubed plus 7.
It'd be the 5x cubed.
Right, it'd be a 3. It should have the highest degree term first. That's how we usually like to write it. It doesn't have to be that way, though. Okay, you could have the highest degree term somewhere in the middle of the problem. Then you have to find it. What do you call it if the highest degree is a 1? What kind of polynomial would that be? Linear. Yep. How about when the highest degree is a 2? That's a quadratic. And when the highest degree is a 3? What is it? Cubic. Cubic. When the highest degree is a 4, you can write quartic. But generally beyond that, you just say my polynomial has degree 5, degree 10, degree 30. Right?
Did you say quintic?
I've never heard the term, but usually that does mean 5. But I'd have to look that up.
How come the 4 is quadratic? Because like quad means 4.
Yeah. Duoratic? I don't know. Yeah. Biratic? I'm not sure. Now, the nice thing about polynomials. Look at all of these polynomials that I wrote down. Are there any square roots in any of them? No. Are there any fractions with a variable in the bottom?
No.
No. So what does that mean about the kind of numbers you could plug in for x?
Plug in it.
You can plug in anything. Right? You can take any number and times it by 3. You can take any number, times it by -5, and then cube that number. Right? You can plug in any number you want into a polynomial, which means the domain of every polynomial is all real numbers. So that's the easiest question I could ask you about a domain question. What is the domain of a polynomial? It's always all real numbers. Now the range depends. If you think of a parabola, does a parabola go up and down forever? No. A parabola might have a minimum and go up forever, or it could have a maximum and go down forever. But you'd have to find that minimum or maximum, okay, in a parabola. So the range, it can depend on the problem. But domain is always all real numbers. Okay. So there's some different cubics. We drew some of those in the last section. The way a cubic looks is kind of controlled by that highest exponent. That highest exponent, if you subtract 1 from it, what's that? That's how many turns it can take. Right? So a cubic has a highest exponent of 3. It can turn twice. There's a turn. There's a turn. Notice I didn't say has to turn twice. I said it can turn twice. You could have a cubic that looks like one of these. It's like it starts to try to turn, never really does, and it just keeps going. So think of a cubic having at most 2 turns in it. That's like a maximum. How about a 4th degree? How many times could that turn at most? 3. So you could get a 4th degree that has like a W shape to it. Has 3 turns. 1, 2, 3. Another way to think of the degree is if you put your x-axis in right there. How many times does it cross the x-axis? 4. So the 4 is the maximum number of times it could cross the x-axis. Depending on how you shift it, you could end up with it only crossing 3 times. You could have something like this. So it just touches it once, and then you get 2, 3. If you shift that up a little bit more, you could get just 2. You could get 1, or you could get none. So there's a lot of different ways it could cross here. So 4th degree polynomials doesn't have to have every single term in it. The more terms it has, the more complicated it starts to look. But the most basic 4th degree is just that. That one looks kind of like this. It looks kind of like a parabola, but the bottom is flatter. If you keep increasing that exponent to even numbers, like x to the 6th, x to the 8th, it just starts to really look like flatter and flatter on the bottom. Then if you start adding in all these other terms to complicate it, then it starts twisting and turning and doing stuff like that. Right, let's try this one. Okay. Are there any exponents here with decimals? Nope. Any exponents with negative numbers? Any exponents with negative numbers there?
Nope.
Nope. So then that means that's a polynomial. What's the domain of it? All real numbers. Domain means you can plug in any number you want. It's going to go left and right forever. Range is up and down. Okay, to figure out the range, the easiest way to do it is just type it in on the calculator and see what it looks like. Now, we've got all the terms third, second, first, constant. So it's probably going to do all the twists and turns, okay, because it's more complicated. So we got x to the fourth plus 5x cubed plus 2x squared minus 8x plus 1. Okay, and then hit graph. Okay, is that a good window?
Yeah, pretty good.
Okay.
See the range.
Can I see the range?
Not entirely.
Not entirely. I don't know how low it goes, and that's what I need to know. So it goes a little bit lower than what I can see. If it goes off the screen, I'm not going to be able to find the range. Okay, so I set my y-min a little bit lower. All right. Now we can see it pretty good. What's the, let's start with the highest. What's the highest that this graph is going to go?
Infinity.
Infinity, yeah. It's never going to stop going up. Now, there's a lowest that it goes, and the lowest it goes is right there. I need to figure out where that is. So if I go to calculate, what option could I use to figure out the lowest it goes?
Minimum.
Minimum. Okay, so to do the minimum, have we done minimum before?
Yes.
Might have. So you just pick a point to the left of the minimum, pick a point to the right, and then do a guess. Okay. So remember, we're dealing with range now. What letter is range? Y. Okay, so the x is not how low the graph goes. Negative 3.2. That's not how low it goes. The lowest it goes is negative 11.95. That's the lowest. Now, do we actually hit negative 11.95?
No.
Yeah, we don't quite hit it.
It doesn't stop there. It just kind of like caresses it.
Yeah, I mean, if you put a bracket on it, that's okay. I mean, I know technically it's like negative 11.949, but we rounded it. So if you rounded it, it would be negative 11.95, and it would hit that number. Rounded. So that's okay. Good question on that one. Okay, so last thing. When you have a graph like a cubic or even like the W shape, and it does something like that, everywhere the graph turns, you get what's called a local minimum or maximum. Okay, this is a local minimum, this is a local minimum, that's a local maximum. When I say that this is a local maximum, I'm not saying that it's the maximum value the graph ever hits. I'm just saying in that area, it's the highest value. That's what a local min or max is. It's just a value that is lower or higher than everything around it. So a local maximum is a point on the graph that is higher than everything around it. And you know what? We could just kind of combine minimum with it. And then just put a point on graph that is higher. And then I'll put lower than everything else around it. That way we don't have to write maximum and minimum twice. So you might see in the homework a question that says to find the minimums and maximums. Okay, the way they usually word that is local mins and maxes are called extrema. So if the question says to find all local extrema in the problem, they just mean to find all the minimums and maximums in your graph. Right, and we'll try one of those, and then that's where we'll stop for today. You pretty much use the calculator. Almost every problem today is using the calculator, so it's a lot of calculator stuff. Okay, let's try this one. So they're asking two things. What is the minimum? Where is the minimum? What is the minimum is going to be a y value. Where is the minimum is the x value. Okay. The x, so the where is the number you would actually plug in for x to get the minimum value for y. Okay, let's try. So we've got x cubed minus 4x. I'm using the same window as the last problem. It'll work fine. Does this graph have a local minimum?
Yes.
Yeah. Now if you have like a line, lines don't have local minimums. For a graph to have a minimum or maximum, it has to turn. Okay, it has to take a turn. So let's do second calc minimum. Pick a point to the left, to the right, and do a guess. Okay, so now let's make sure we know what we're looking at. What is the lowest value that that graph hits in that area?
3.07.
Negative 3.0, we're going to round negative 3.08. So the min is negative 3.08. Now the second part of the question is, where does that happen? So this happens when, so this is like, what number would you plug into the formula to get negative 3.08?
Would be just 1.5.
You would plug in 1.15. That's the x value. That's the where. So the minimum is negative 3.08. And this happens when x is 1.15. And maximum, I think in this problem, the minimum and maximum they're like mirror images of each other. I think it's negative 1.15,
Yeah.
positive 3.08. But you answer the question the same way. So just remember, minimum is the y value. Where it occurs is the x value. Okay, so I'm gonna adjust the homework a little bit, but I'll give you a chance to copy that, and then I'll put up the homework. Okay, so on page 116, there's 1, 2, 3, 4, 5, 6, 7 questions. And they're going to mention in the directions to do this thing called a sign pattern. That's not the way I taught you how to do it. Just use your graphing calculator to find either the roots or the intersection. Depends on how you do it. And then on page 149, it's 1, 9, 10, 16 through 20 just evens, and then 38 and 39.